Angie, the branch manager of Citibank, and she wants to improve the service of the bank by replacing the teller with an ATM. She observed that the average arrival and the average number of clients serviced per hour remain the same. Because an ATM processes according to a fixed cycle, she presumed that the service rate distribution is now constant. This is the reason why we are having now the third model MD1, where the service time distribution is constant. The figures are summarized in the table on the next slide. How many clients are waiting to be served? How much time does a client is waiting? How much clients are at the ATM at any given time? And lastly, how much does a client spend at the ATM? Hello everyone, so welcome to our next topic regarding the different models of queuing theory. So this is actually our third model of queuing theory, which is MD1. Ayan, MD1 ang notation niya, no? So let's start our discussion with this third model of the queuing theory. So again, model number 3, MD1, and this notation represents for the letter M, that is the arrival distribution. Still, we will be having a Poisson distribution here, while for the service time distribution, we will not be having exponential distribution na ngayon, no? Dahil dito po, D stands for constant. So, constant na yung magiging time natin, yung service time na meron tayo, and not exponential distribution anymore. Okay, so for the third part of our notation, that is the number of service channels open, or basically this is the number of servers open, and that is 1, no? The small m, that is number 1 sa ating model number 3. So let's have our example para mas makuha ninyo. Citibank pa rin tayo. This is the fifth na problem regarding Citibank. Continuation ito ng mga naunang problems natin. So we have here Angie, the branch manager of Citibank, and she wants to improve the service of the bank by replacing the teller with an ATM. She observed that the average arrival and the average number of clients serviced per hour remain the same. Because an ATM processes according to a fixed cycle, she presumed that the service rate distribution is now constant. This is the reason why we are having now the third model MD1, where the service time distribution is constant. The figures are summarized in the table on the next slide. How many clients are waiting to be served? How much time does a client is waiting? How much clients are at the ATM at any given time? And lastly, how much does a client spend at the ATM? Now, let's have our additional question here, which is, what is the probability that the ATM is occupied? What is the probability that there are no clients? So, ayun yung mga kailangan nating sagutin ngayon. And our data here is, again, for the M, number of ATMs, this is 1. For our lambda, that is arrivals per hour, 11 tayo. And for our mu, service per hour, that is 12. Ito yung kung gaano karaming nasa-serve nila per hour, no? This is the one that is constant. Okay? So, now guys, let's have now our solution, no? Considering the fact na ito yung data natin. Actually, pareho po ito yung given natin sa ating model number 1, which is the MM1. No, it just so happen na ngayon, constant ang distribution natin for the service time. Okay? So, let's set up the statistics table. Ito po yung mga kailangan natin na isolve at lagyan ng value mamaya. So, average clients waiting online, that is represented by L sub Q. Average waiting hours per client, that is W sub Q. Number of clients in the system, that is letter L. Average hours client spends in the whole system is W. For the row, that is the probability that the ATM is busy, and yung counterpart niya, the P sub 0 is the probability that there are no clients. So, let's start our computation. For the first one, let's compute the average number of clients waiting in line. Guys, take note, sa line lang po ito, sa pila, kung gaano kahaba yung pila. No? on the average, hindi siya sa buong sistema. Kasi when we say whole system, kasama po yung mismong service time, yung nandoon na siya sa server, si client. Okay, so that is two different things kasi. So for this, number 1, our formula here is L sub Q equals lambda squared all over 2 mu multiplied to mu minus lambda. So as you can see, etong LQ, if you still remember our formula for LQ on the model number 1, the MM1, parehong-pareho po, nadagdagan lang ng 2. Not just for the L sub Q, but also on the other formula. Mamaya makikita niya kung ano-ano pa yon ng mga formulas na yun. Nadagdagan ng 2 for the denominator. That is for the constant for the model 3 MD1. Okay? So, our lambda is 11. So, 11 squared here over, let's have 2 multiplied to mu, which is 12. And, of course, 12 minus 11. Okay? So, we can actually direct this on the calculator. Let's have here the fraction bar, 11 squared. And for the denominator, let's have here 2 times 12 multiplied to 12 minus 11. Okay, the answer is 5.0417. So, 5.0417. Let's write this on our statistics table. 5.0417. Okay, so that is the average clients waiting online. So, somehow, mas maano to, no? Kasi pinalitan nila eh. Pinalitan nila ng ATM yung mga teller instead na tao doon, ATM na, kasi naniniwala sila sa ATM daw is fixed ang ating service time, no, constant nga. And kung tingnan ninyo, no, mas mabilis ito or mas kaunti ang pila compared to before na umabot yata ng 10, no, if I'm not mistaken. Ito 5 lang yung average na bilang ng tao na nandoon sa pila, no. So, next tayo for the WQ. For the WQ, number 2, compute the average number of hours a client waits in line. Ito naman is kung gaano naman katagal naghihintay. No? So, W sub Q formula here is lambda over the denominator natin na 2 multiplied to mu minus bar. So, the only difference is wala siyang squared. No, pareho lang po. So, let's have it here. Oops. Kakasabi ko lang, no, walang squared. Nakopya ulit. Okay, so delete natin. So, 11 over 2 multiplied to 12 multiplied to 12 minus 11. Okay, so let's direct this on the calculator. Delete na lang natin itong square na yan. Answer is 0.4583. So, this is 0.4583, the number or the average number of hours a client waits in line. So, wala pang 30 minutes ito. No, 0.5 and 30 minutes. So, wala pang 30 minutes yung pila nila. Dahil nga, constant na ang ating ATM. Okay? So, isulat natin dito, 0.4583. Okay, next natin for the number 3, compute the average number of clients in the system or the letter L at any given time. In the system, included ang nasa server. Okay? So, number 3, the formula here is L equals L sub Q plus lambda over mu. Okay? So, our L sub Q computed is this one, 5.0417, copy lang natin, plus our lambda which is 11 over our mu which is equivalent to 12. So, the answer is, direct tayo sa calculator. Let's clear this one, 5.0417 plus 11 over 12. Okay, that is 5.9584. So, let's have it here. 5.9584. Ito yung bilang. Dapat, guys, no? Dapat ito somehow mas mataas sa computed value ng L sub Q natin. Dahil ito is yung kabuuan na bilang, no, on the average, of course, ng mga tao na nasa system, not just on the line. Dahil again po, this is the line, if this is the server, so ito yung L sub Q. Kapag sinama mo pati yung server, ito yung kabuuan niya L. Okay, kaya dapat mas mataas yung value. Okay, so let's write this here. 5.9584. Okay, so next, we have the fourth one, the W. So, compute the average number of hours a client spends in the system. Gaano naman katagal ang client natin sa system and not just on the line. Ito kasi sa line ito. So, our formula here is W equals WQ, yung computed value ng WQ, which is this one, plus 1 over mu. So, let's have it here, 0.4583 plus 1 over, our mu is 12. So, direct natin sa calculator, 0.4583 plus 1 over 12. Answer is 0.4583. Sorry. This should be decimal point. 0.4583 plus 1 over 12. Answer is 0.5416. Okay, so 0.5416. Ito yung sinasabi ko kanina, no? Almost the same with 1 and 3. Itong 2 and 4, dapat mas mataas ito. Yung computed average number of hours a client spends in the system, which is 0.5416. And mas malaki siya doon sa line, dahil ito line lang. Ito kasama yung server. So, 0.45416. Kung gusto niyo ma-change into minutes, you can convert it naman. Average hours client spends in the system, W, 0.5416. Okay? And we're done with the first 4. So, next tayo. Number 5 tayo. So, for the number 5, this is the probability naman that the teller is BC, or this is typographical error. Napalitan na nga po yung teller, wala nang teller. No, ang meron tayo ngayon is ATM. This is the probability that the ATM is BC. Ayun, no, probability that the ATM, not teller, guys. No, take note na lang on your notes. So, let's have here the formula. So, for the formula of rho is equivalent to lambda over mu, and that is 11 over 12. So, basically, 11 over 12 is equivalent to 0.9167. So, 0.9167. Or around 92% na siya, no? Ganon ka-busy si ATM. Kasi bukod sa mag-isa siya, no, okay, may dating, no? May dating ng may arrival, okay, arrival natin medyo mataas. Tapos mag-isa lang siya. Pero constant naman kasi. Kaya somehow na-utilize natin si ATM. And hindi na tao, no? Hindi na exponential yung distribution, constant na siya. So, katumbas niyan, of course, yung number 6. By the way, before tayo mag-proceed sa number 6, let's write this on our statistics table. No? 0.9167. Okay? So, almost 92%, no? Let's now move on to the last one, which is the number 6. The probability that there are no clients at the ATM, or the P sub 0. So basically, this is just the counterpart of the idle time, or rather the busy time of the ATM. That is the idle. Yung number 6 idle, yung busy yung 5. So meaning to say, the formula for P sub 0 is equivalent to 1 minus rho. And this is 1 minus 0.9167. This is equivalent to, let's have here, 1 minus 0.9167, 0.0833. Okay, so 0.0833. This is now the probability that the ATM is idle. If we wanted to convert this into percentage, more likely around 8.33% yung idle time, then yung BC is around 91.67%. So, mas busy si ATM ngayon, no? Isulat natin siya dito sa ating statistics table, 0.0838. So, we are done now with the first problem. Tulad ng mga nakagawian, no, may kadugtong pa po ito, which is the problem 2, all about the costing naman. Ano naman yung naging impact ng ganong queuing system with regards to the cost. So, we have here the example number 2, Citibank pa rin. And kadugtong nga, no? Angie, the branch manager, knows that with the ATM as the teller, the number of clients waiting in line will decrease. She observed that the ATM's service cost is equal to the labor cost of a teller. Oh, pareho lang yung cost nila, no? Mas okay pa si ATM kasi constant, hindi siya napapagod tulad ng tao na teller. No, and the average opportunity cost of clients who are waiting remain the same. Figures are summarized in the next slide. How much is the total cost per shift? Okay? So, the table is here. Service cost per ATM, which is equivalent to $5 per hour. That is the C sub S. Next description, we have the cost of waiting, which is equivalent to $6 per hour. That is C sub W. And the working hours per shift is 8 hours. Okay, so we need to complete this cost table. Tulad nung dati, divided po natin siya into per hour and of course, times 8 lahat ng data per shift. For the total service cost, total waiting cost, and of course, the totality of the whole, no, the total cost. So, let's have here our computation for the cost table. So, for the first one, let's start with the computation of the total service cost. So, let's have it here. Total service cost is represented by T sub S. Per hour muna tayo. Equivalent ito sa M multiplied to C sub S. What is our M? M is the number of ATM. And meron lang tayong isang ATM. So, 1 multiplied to CS. What is CS? Service cost per ATM. Magkano yung service cost of running the ATM? So, more likely, ito is kasama na dito yung depreciation ng machine. Kasama na dito yung tawag dito yung kuryente or yung mga iba pang kailangan na para tumakbo si ATM para mag-run siya, para mag-work siya. So, that is $5 per hour. They have the basis for that. So, 1 times 5 is 5. So, per shift naman tayo ng total service cost. So, total service cost per shift, this is equivalent to total service cost ng per hour. Multiply natin kung gaano ba katagal ang isang shift. Which is yun yung H natin. Ito nga siya. 8 nga daw sabi dito. Okay? So, basically, this is 5 multiplied to 8 and this is 40. Okay? So, may ilalagay na tayo sa unang part which is equivalent to 5 and 40. Okay? For the total waiting cost naman, number 2 tayo. Total waiting cost stands for T sub W. Per hour tayo and kuhanin din natin siya ng per shift. Okay? So, yung per hour na to, formula niya is lambda multiplied to W sub Q multiplied to C the sub W. So, our lambda, guys, is, if we will go into look back on our given, no, or even sa solution na lang, our lambda here, ang ginamit natin na lambda is 11. So, let's have 11 here as our lambda. 11. And for the WQ, our computed value for WQ kanina is, ito po, 0.4583. So, let's have here 0.4583. And for the CW, given na siya dito sa previous slide natin, that is equivalent to 6. Okay? So, let's go to our calculator and have the value for this. Clear natin. 11 multiplied to 0.4583 multiplied to 6, that is equivalent to 30.2478. So, let's write it here. 30.2478. Ayan, ang value niya dito sa total waiting cost per hour. 30.2478. So, we need now to compute naman sa value niya per shift. And yung per shift na yan, oops, may 11 na dito. That is T sub W per hour, kung ano man yung na-compute natin doon, and multiply lang po natin sa hours per shift, which is equivalent to 8. Therefore, 30.2478 multiplied natin into 8. Okay? So, let's compute this. Ito yung kanina, no? Dagdag lang tayo ng times 8. And that is equivalent to 241.9824. So, 241.9824. 24. Okay? So, ilipat natin itong value na to doon sa ating cost table para 241.9824. Okay? So, ano naman tayo? Sa total cost naman tayo. Compute the total cost. So, basically, for the total cost per hour natin, this is equivalent to the total service cost per hour, T sub S per hour, plus the value of the T sub W per hour. So T sub W per hour. And let's have the equivalent values, which are 5 and this one, 30.2478. Okay? And basically, this is equivalent to 35.2478. Okay? So, let's now go naman sa ating total cost na per shift. Okay? So, since this is per shift, basically, this is equivalent to the total cost, no? The total service cost. Ito po, total service cost per shift plus the total waiting cost, ito, pangalawa, per shift. And this is equivalent to itong 40 plus, let's have this, 241.9824. And basically, this is 281.9824. So, isulat natin, no? 35.2478. 35.2478. Actually, pwede mo diretso na, no? I-add mo lang yan dalawa. 281.9824. Okay? So, this is our final cost table. As you can see, 540, almost the same with our cost table ng Model 1, MM1. Pero nagkaiba lang sila dito sa total cost. And with that, our conclusion is, no, while the total service cost of 40 is the same with a teller, ayun nga yung sa MM1, Angie should expect a smaller, take note guys, a smaller total cost of 282 because of the opportunity lost of only 242 for an ATM. Yung tinutukoy na opportunity loss dito is the total waiting cost, guys, no? So, okay, malito doon. 242 lang daw. Bakit yan nasabi niya? No, kasi to be honest, as you can see, if you still remember, ito po yung table natin, cost table for the first model, MM1. 540 rin ito. Check natin, 540, tapos ito sa MM1, 540 rin. It just so happen na mas maliit yung waiting cost natin ngayon, 30 and 241 lang, kaya yung total cost per shift is 281 lang. Malayong malayo sa total cost per shift nitong Model 1 natin, which is 524. So, meaning to say, parang sinasabi niya dito, na mas maganda pa rin na mayroon tayong ATM na palitan na yung mga teller, no, tanggalin sila, palitan ng ATM. Dahil, with that, mas maganda yung service, constant yung service rate, and in return, of course, masasatisfy mo si customer. At the same time, mas maliit yung total cost ninyo. No, this is how queuing theory is applied sa third model po natin. We still have our fourth and last model ng queuing theory. But for now, I hope you learned something from this presentation, guys. Thank you for being with me on this topic and keep safe always. May you enjoy the rest of the day and of course, the rest of the week. Bye-bye everyone. See you on our next topic.